Okay, right, so this is lesson 2 for grade 10 standard. We are going to still look at criteria B, looking at some of the answers people put. Again, there's still some misconceptions people are making when it comes to criteria B. There's so many videos me and Miss Beth made, there's so many examples. We should be at a point now where we're all up to the justification, and we're just not quite there. So what we're going to look at today is, again, yesterday was arithmetic sequences, today is going to be quadratic. So this do now task is going to remind you how we do quadratic sequences. So first thing we need to do is work out the difference. So this is plus 2, plus 4, plus 6, plus 8. And then because the difference isn't the same each time, you say, okay, well that's plus 2, plus 2, plus 2. So when the second difference is the same, that's how we know it's a quadratic sequence. So we just take the second difference and we'll always divide it by 2. And that lets you know what goes in front of n squared. Okay, so remember, not quite there. So n represents 1, 2, 3, 4, and 5. Okay, so if I write n squared, if I substitute 1 into this, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and then 25. But if you look at the actual sequence here, it's 1, 3, 7, 13, and 21. So you have to say, okay, well, how do you actually go from n squared to the sequence? The first one, you don't do anything, you add 0. To go from 4 to 3, you minus 1. 9 to 7, minus 2. 16 to 13, minus 3. And the last one is minus 4. So then if you look, you should notice that this is an arithmetic sequence because it's going down by -1 each time. So that's going to be negative n. But how do you go from -1 to 0? You have to add 1. So then the rule for this quadratic sequence, don't forget you have to put your n squared back in, is going to be, should really write it below, let's not do that, is n squared minus n plus 1. Okay, so hopefully you've just watched that and thought, yeah, remember doing this in class. There's also another breakdown a little bit below if you want to go and look at that at your own pace. But that is how we do quadratic sequences. Okay, so again, we did this in last lesson, things we need to know. So you might be asked to describe something, predict more values in the table, state the rule, test, verify, and justify. Okay, and we need to be looking at how many marks the question's worth. Always, it's about 30 marks. Shouldn't take no more than 30 minutes. I would suggest you write on paper and then copy over later. Okay, so these tasks are on Assess Prep. That's just another example that you can look at. So you work out the first difference, the second difference, and so on. Right, we're going to have a look at this question today, and we're going to have a look at justifying using what we know. So this is what I'm going to do in class, and then you can go and try the rest. This is what I was talking about yesterday in a question. They will give you extra information. You might or you might not need them. Okay, so if we go and look at the question, it wants me to describe in words the pattern for P. So if you look at the top, it's talking about rectangles, stage 1, stage 2, stage 3. We've got the length, the breadth, the perimeter, the area. Okay, so the first one says, what is happening with the perimeter? So hopefully you look and you can say that it increases by 4 each time. Okay, increases by 4 each time. So that means it's an arithmetic sequence. Okay, you can also write it's an arithmetic sequence. That one's done. It says predict values and and enter those values in the table. So it doesn't actually ask which column, so we're going to do them all. So the first one for the length is 2, 3, 4, 5, 6, 7. The next one is 1, 2, 3, so 4, 5, 6. The perimeter is 4, 10, 14, so we just worked out it's going up by 4s each time. And then the last one is plus 4, plus 6. So it looks like the second difference is going to be plus 2. So that'll be plus 8, plus 10, plus 12. So that's going to be 20, 30, and then 42. So we know that the area is a quadratic sequence. Okay? Right, done that bit. So write down the general rule for P in terms of N. So that's just for perimeter. So I'm going to do this at the bottom. Okay, because it's going up by 4 each time, it's just 4n. But if we look, 4 should be 4, 8, 12, 16. But our sequence isn't. We're going to have to add 2 to the 4 times table for the perimeter. Okay, so P equals 4n plus 2. Right, write down the, so that one's done. Write down the general rule for A in terms of n. So again, if we go up to this one, we can see it's a quadratic sequence. I'm going to need a little bit more space for this. Because the second difference is 2, I know that if I divide this by 2, it's n squared. So I'm going to write the sequence, which is 2, 6, 12, 20. N squared would produce 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Right, then I'm going to have to work out the difference between n squared and the actual sequence. So that's going to be plus 1, plus 2, plus 3, plus 4. So this is an arithmetic sequence within itself, and it's nice and easy. It's going up by 1, and it starts from 1, okay? So that arithmetic sequence is just n, but don't forget you have to add that to n squared, okay? So A equals n squared plus n. So that's the second one done. Then it says test. So when you're testing, it wants us to test them both. You need to be putting in the numbers. So test we were given. I'm just going to put the number 2 in. Okay. So for perimeter, so n is 2. For perimeter, I'm going to have 4 times 2 plus 2, which is 10. For area, 2 squared plus 2. And that's going to give me 6. You can see that they match, so you have to write that sentence, okay? So this matches the value in the table, therefore my rules are tested. Right, so that's test done. Now we're going to verify and then justify after that. So verify, you're going to do exactly what we've just done, but you need to put the numbers in that you predict, okay? And you can pick any of them. I'm going to pick 5. So n is 5. So that means my answer should be 22 and 30. So the perimeter, we're going to have 4 times 5 plus 2. That's 22. Area is going to be 5 squared plus 5. So that's 25. So that is 30. So they match. So you need to write this sentence again, but instead of writing that it matches the table, we say that it matches the prediction. It matches our prediction. So therefore, it's verified. Okay? Right, so up to that point, everyone should be okay. You should be able to predict values in the table. You should be able to find the general rule, and then you should be able to test and verify. Okay? Right, I'm going to take this off now because I want to go and show justify. I feel like justify now is what we should be spending our time on, okay? We've spent so much time looking at everything else, okay? Right, so justify. So we need to get the rule for perimeter. So perimeter is 4n plus 2. And the area, which is n squared plus n, we need to get these two rules by using what we know in the question. Okay, so go back. Look, we'll start with P. So P, what is P? So P is talking about the perimeter of the shape, so adding all the sides together, okay? Because we've got to do it algebraically, we need to write the length and the breadth as a rule in itself, okay? So we start with the length. You can see that it's increasing by 1 each time, so it's just n. But because it starts from 2 and not 1, we need to add 1. So that is the general rule for L. And then the general rule for B is just n, because it's just going up in ones and it starts from 1. Okay? So, how do you work out the perimeter of a rectangle? You add all the sides together. So, I'm going to add all the sides together, but I'm going to be using this as my length and this as my width. So, n plus 1 plus n plus n plus 1 plus n. It might help if I show you a visual of what I'm doing, okay? So I'm calling the sides n and n plus 1 instead. So the perimeter of this shape is n plus 1 plus n plus n plus 1 plus n. So then how many n's do I have? I have 4. And then 1 plus 1 is plus 2. And that is justifying the perimeter without doing sequences in terms of just for the perimeter. We've used other information, which was the perimeter of a rectangle. Okay, going to do the same again, but this time it's for area. Okay, so still the same rectangle, but area, we know that when we do it, we have to multiply these two together. Okay, so I need to multiply them. So I need to do n multiply by n plus 1. So if I expand that bracket, I'm going to get n squared plus n for the area. And again, this matches the rule. And that's how you justify by getting the rule using a different thing. Okay, I'm going to stop there. What I'm going to do is I'm going to go and answer the other 2 questions by hand, and I'll post them onto Google Classroom a little bit later. So your task now for this lesson is you need to go to Assess Prep, and you need to have a little look at your class code for Wednesday. It's on Google Classroom, and that should be okay.